Hello everyone, welcome to Perfect Coding Explanations with me, Omar, and today we're going to be looking at the problem twosome from Leetcode. This is question 1 from Leetcode and is considered one of the most elementary array and hash map problems, so it's the best question to start off with in my opinion, and the best question to start thinking programmatically if you are new to data structures and algorithms. So today we're going to look at two approaches, the more intuitive brute force approach followed by the most efficient way by utilizing a hash map, also known as optimizing for speed and having the most efficient big O performance, which is what companies want to see most because to them speed is everything. So without a further ado, let us get into it. So let's read the question. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So here we have an example. Input nums is equal to an array of ints, which contains 2, 7, 11, and 15, and the target is 9. So we could just look at it real quick, and we understand that it's probably going to be 2 and 7, because 2 and 7 equal 9. And we understand it's the item at the first position of the array and the second position. Now remember, arrays are 0 indexed, so that means the first element is at position 0. So when we return the output, it will be an array of 2 elements, referencing the indices of the correct numbers of the array. So the item at the 0th position, which is 2, and the item at the first position, which is 7. So we want to be able to do this for any set of inputs that we get. So first we're going to look at the brute force approach, which is generally, if you don't know how to do this question, the brute force approach is the more intuitive approach, and we can take a look at that now. So let's open our whiteboard. And here we have a problem. Nums is equal to 2, 7, 11, and 15. But the target is 26. So in the example on Leetcode, the target was 9, but the first two numbers would have given us that. So you don't really get to see how the process is going to work if your very first try is going to give you the numbers. So we made it a little bit more challenging. So we have our nums array, 2, 7, 11, and 15. So we have, and this is at index 0, and this is 1, this is 2, this is 3. And so we're going to have our first for loop. Let's use the variable I to indicate where the first for loop is looking. So our first for loop is looking at index 0. And we are going to start by looking at item 2, like this 2 over here. And that is what I is looking at first. And so our second for loop is going to iterate over every element after, in this case, 2, or anything after the 0th index, because that's where I is. And it's going to be looking at the sum of those two numbers that are at those indices. And it's going to be checking if it equals the target. If it doesn't, we just keep going. If it does, we're going to return an integer array of those two indices. And those are going to be representative by the variable I and our second for loop, so which would be j. If we want it to represent the item right after I, the way we indicate that is just I plus 1. So that's what our second for loop is going to be looking at. And so the way it's going to work is that we're going to start with I is equal to 0, which is at 2, and then j is going to start at 7. So I is here, j is going to be here. And obviously 2 plus 7 doesn't give us 26, neither does 2 plus 11, and then neither does 2 plus 15, because then j is going to be moving on every time we don't find that sum. If we don't find it even by the last element, then I is no longer 0. I is going to increment to the next spot. It would be at index 1, and then j would start at 1 plus that. So I would be here, and j would be here at 11. So we're going to be looking 7 plus 11, 7 plus 15. Obviously, those are not going to give us 26 either, and then I is going to move to 2, and j is going to move to 1 plus that. And then obviously, where I is equal to 2, that means that it's going to be 11, and then plus what j is at, 15, it does give us 26. So at that point, we're going to return a new integer array of those two indices, which are representative of where the variables are at. When I is at 2, that's when it equals 11, and then j, it would be at 3. And this would be our solution. So let's go ahead and program that out. So we have a for loop that we want to start off with, where int I is equal to 0. And while I is less than the array length, we are going to keep incrementing it. And we're going to make a second for loop that gives us another variable that is also incrementing from every value after. So we can use j. Normally, the nomenclature is that we're just going to be using I for the first for loop. If you ever need a second for loop, then we usually use j. And sometimes if you need a third for loop, you use k as well. But then at that point, the efficiency has kind of gotten out of control. It doesn't happen a lot, but it does sometimes happen. So it's good to keep in mind of these variables, which are often used. So j is going to be equal to I plus 1. And it is also going to be running until the end of the array. And we are going to be incrementing that as well. Oops, I accidentally wrote I there. It should be j. And it should be j plus plus. All right. So in the second for loop, once we have our two variables, we are going to be looking for the sum of the two items in the location of those indices with respect to the nums array. So in sum is going to be equal to nums of I plus nums of j. Now we should create a condition that if that item, if that sum is equal to the target, then we can return its indices and we're done. So we're going to have an if statement. If sum is equal to the target, then we can return a new int array with the items I and j. That would work, but we still have to tell Java that, like, we know that there's always going to be a solution, and that's good for us, but Java doesn't always know there's going to be a solution. Java is a universal language. So Java definitely wants us to return something no matter what, even if our arrays don't have the answer we're looking for. So there's a couple of things we can do, but the most simple thing we can do is just return null. And if we don't find the elements, at least Java's happy we're returning something. So let's give that a run. And that looks good. All right. So our efficiency is actually not too great here. It's okay, but it happens to be big O of n squared because we have two for loops. So a for loop runs n times if you're running for every element in the array. And if you do that 2 times, it's going to be n times n, or n squared. No, this isn't exactly 2 times. This is actually n over 2 times, because you're not running the whole array for every value of I. You are doing it 1 less each time. So, just from a math perspective, this is just something that you'll learn over time. But if you're doing 1 less every time, that's actually n over 2. But because it's still proportional to n, we still simplify that by saying n squared. So this is still a big O of n squared solution. That's not really efficient when it comes to these types of programming problems. So let's take a look at a more efficient solution, and we can begin programming that as well. But first, let's whiteboard the solution just to give us a better idea of how we're going to code it out. So this time, instead of using 2 for loops, we're going to be using a hash map, a data structure where it's going to keep track of indices and the values at those indices. So we don't have to do a second for loop to iterate through all of the values. It is all going to be contained in this data structure. Now, hash maps are actually really unique in that they actually have O of 1 lookup time, which means they can, for all intents and purposes, look up something pretty much instantly. So they don't have to iterate through where everything is in some sort of data structure like in an array. What they do is they use a hash function to sort of break down the value that or the key that you would want to store, turn it into a code or something, and then that code is representative of a location in memory. And that is a much faster way to be able to find something because you don't have to iterate through all of the other elements to do so. So let's start again with our array. We have 2, 7, 11, 15. Now, we're going to create a hash map. We'll just call it map. And we are going to just have one for loop. So here are the indices 0, 1, 2, and 3. And our hash map is going to keep track of what we have in front of us. So we're going to be starting with when our for loop is at index 0. So we'll just say I is equal to 0. We'll have 2 in there. And so we'll always check in our hash map to see if the complement value is there. So what the complement value is that we have our current value, in this case it's 2, and we have our target, which is 26. So we would do our target minus our current value, and that would give us our complement value, that value which is perfectly added to our current value to give us the target. In this case, the complement would have to be 24. There is no 24 in the map, so we can go ahead and add 2 to the map. And we would have our key, which is our value up there, 2, and the index. So it's usually denoted with a colon, but you don't really have to worry about that for this. And now we have our first entry in there. Now for our second iteration, now I is going to be equal to 1. We check to see if the complement value is in there for 7. So obviously we're going to check 26 minus 7. 26 minus 7 is 19. 19 is not already in there. We only have a 2 in there. So we can go ahead and add the 7. The item and its indice. Same thing for 11. Obviously 15 is not in there. 15 would be the perfect complement value for 11 to give us 26. It's not in there. We can go ahead and add 11 in there. And then finally 15. 15's complement value is in the map. And so we don't have to add 15. That would be a redundant operation. Because the complement value is in there, that should be presented as an if condition. The complement value is in there, so return the value. So at this point, the index should be 3 because we're at the value over here. We're at 15. So we have 3 saved over here, and we know the complement value is there, so we can ask the hash map to get us 11's value. 11 is the key, and so its value is 2. So we can return those 2 elements. So we can just return an integer array of 2 values with whatever I is currently at and with whatever the complement's value was at, which is 2. So we'll have 3 and 2. I'm pretty sure the question said it could be in any order, so order does not matter. And so that is the correct answer for our more efficient solution. So let's go ahead and code that up. So we start by declaring a hash map. We could do a more versatile way where we just call it a map, and we could do integer, integer, because it's going to have an integer as the key and an integer as the value. And then map is equal to new hash map. So we can use a hash map. And we have a for loop, int I is equal to 0, while I is less than nums.length I++. And now we want to declare the complement. The complement is going to be that perfect value that is going to pair with the current value, but it's subtracted by the target. So int complement is going to be equal to the target minus nums of I, which is the current element. Now we are going to do an if condition. While we are using the hash map, we're going to check to see if our complement is already in there. So if the map does not contain the key, which is the complement, then we can go ahead and add the current element into the hash map. Otherwise, if the complement is already in there, and so that there is a key that is the complement in the hash map, we have everything we need. We can return the new int array, which would contain the current iteration of I, and we could get the complement. Get complement. And that's everything we need. And then obviously, just for Java, we have to tell it that we need to throw an exception or return something. This time we can go ahead and throw an exception. So we can throw new illegal argument exception, just to indicate that no match was found. Let's go ahead and run that. Oh, forgot the semicolon there. And it's been accepted. Perfect. So there is our much faster solution. So the complexity of this, the efficiency is O of n, because we just have the one for loop. We do take up a little bit more space because we are using a hash map, but we are able to complete everything a lot faster that way. So it's definitely a big plus that we are using some sort of data structure to compensate for that time. And just to end the method, you either have to throw the exception saying no match was found, and that will tell Java that's like it's returning the exception. Or you could return null, or you could return an empty integer array. That doesn't really matter. The point is the question told us that we were going to have an answer in every array nums that was given, so that's good. Let's take a look at some other acceptable answers, just so we can maybe deep dive a little bit more if you want to. Otherwise, that's pretty much all there is. This is just something if you really want to increase your knowledge in some of these other concepts. So we had our 2 for loop solution. Here we have the solution that we presented right now. The answers can have some variance here or there. So in this one, we're just using a map. You could also declare it a hash map. Things are a little bit different. Your if statement could have the negative case second and the positive case first. And then you could return something different down here. So in this example, we're using the positive if we're using the if statement positively first. So we're checking to see if it does contain the complement. Then we're just going to return our integer array, and if not, then we are going to add the element to the hash map. And in this case, we're just returning an empty integer array because it doesn't really matter what we return. Java just wants us to return something. That's just how Java works. And so we're satisfying that criteria. There's still some more variants that we can go over. So here you could also declare it as a hash map first. Now, the difference between declaring it as a hash map first versus just a map is an interface. A hash map is a concrete class. So it's generally good programming practice to program to an interface rather than a concrete class because it's more versatile. There's something called loose coupling, and things become more cohesive that way if you program to a map instead of a hash map, so an interface instead of a concrete class, because later on you could decide, oh, I don't want a hash map. I want this map to be a tree map, for example. Now you don't have to completely change like how you coded this hash map here. You could just say this map, and you program to a map, so you're using the interface classes, the interface methods. You could just keep it as is, and you could make this into a tree map instead, and you wouldn't have to completely refactor your code. A lot of companies like it when you program in a more versatile way. They'll definitely see that as a plus going forward. Here we sacrificed some space, so we saved some of these things to variables. It does make it a little bit more readable, but you save things to variables, so you made it the tiniest bit slower. Different companies are going to approach this differently. Sometimes they want readability and not at the expense of efficiency, and here's like very little efficiency that would have been increased here, so you could do this either way. Here I saved my variables to an integer array that I declared at the beginning. Again, we saved it to memory, and then that could be a costly operation in some cases. And so you kind of have to like do this either way depending on how the interviewer wants it. Generally, I would suggest to do it this way, where you return a new integer array where you're only allocating space if there's an answer, and then that's a better way to do it because if there's no answer, you would have just wasted some space. Yeah, and then we just return the array that way. So those are some of the examples that we have. The efficiency is above 98% for pretty much all of them. If you have any questions, feel free to comment down below, and feel free to subscribe or like if you feel like you want to see more videos like this one. But that's all for now, and see you next time.